Hello, and welcome to the latest episode of Shaken Not Burned. We often talk about the energy transition as though it's mostly about building new infrastructure, new power plants. But for many organizations, one of the biggest opportunities lies in improving the performance of infrastructure that already exists. One of the ideas we've been exploring throughout this arc is that the challenge isn't simply building better systems. It's operating existing ones under increasingly difficult conditions. The demands placed on our buildings are changing rapidly. Energy systems are evolving. Extreme weather is becoming more common. Digital technologies are transforming how facilities are managed. And organizations are all being asked to become more resilient, something we can't all agree on what exactly that means in a world where much of our built environment was designed for an environment that existed decades ago. And few places illustrate that challenge better than the buildings where we live, work, and spend much of our lives. Today, those buildings are expected to be more efficient, more resilient, more connected, and more responsive than ever before. Yet behind the scenes, they are constantly responding to changing demands. They're managing energy and heating and cooling and ventilation and security, as well as increasingly adapting to the pressures that didn't exist when they were first designed. So, in order to discuss this, we're lucky enough to be being joined by Katie McGinty, who's the Vice President and Chief Sustainability and External Relations Officer at Johnson Controls. So, welcome to the show, Katie. Could you tell us a little bit about yourself and how you got to where you are?
Sure. Well, greetings, Felicia, and thanks so much for having me. So, mine has been a little bit of a winding journey that has had a couple of through lines. And those through lines have typically been in the intersection of energy and the environment, and where technology can play a role in making it so that we can both have abundant, affordable energy while protecting the environment. And we'll dig into some of those technologies. But the journey for me has been a little in government, a lot in the private sector. And so I've had the privilege of serving in the White House with President Clinton and serving as Secretary of Environmental Protection in my home state of Pennsylvania. And now, for 7 years, being Chief Sustainability and External Relations Officer at Johnson Controls. And we are a 140-year young company that is similarly about bringing the technologies together and putting them in the market so that we can drive our economy, our mission critical enterprises in a way that's protective of the environment.
Well, it sounds to me like you're exactly the right person for us to be talking to. So, let's start with visibility, with what we can actually see, because the majority of us do spend most of our lives inside buildings. What's happening behind the scenes every day in order to keep large buildings and critical infrastructure actually operating safely and comfortably?
Well, we're at an inflection point with buildings. We think of AI now and digital systems. So much of the built environment still lives in the old world of analog. And we saw this in the height of the COVID shutdowns. So during that time, there was a plummeting of 80% reduction in occupancy in commercial buildings. But we only saw a 20% reduction in the amount of energy consumed by those buildings at that same time. Now, why is that the case? And the reason is that most buildings are a giant on off switch. They are analog. They have not matured into the digital age where, of course, we would adjust the parameters to meet the occupancy, who's in the building where. But now digital systems are coming to the fore in a way that buildings can go from inert brick and mortar to much more organic, agile, adaptable systems that are a heck of a lot better for human health, as well as being a heck of a lot better for the planet. And, to take one stat, buildings represent 40% of global greenhouse gas emissions. When we turn the intelligence on in a building, we literally can change buildings from climate problem to climate solution.
That is a beautiful image, because one of the challenges that we are all dealing with is that we're constantly looking for a technological silver bullet that's going to stop us having to change the way in which we do things. Now, as you say, COVID saw a drop in occupancy of 80%, but not a massive shift in energy consumption. We need to find a way of making the things we have work more effectively. And that's more than just more efficiently, which is why I was so interested in what you were saying about health. But I think where I'd like to go is what does that mean strategically? So we're constantly hearing that operational performance and climate resilience and building management and how that affects the role of buildings. This is now becoming board level. This is something that is fundamental to the operation of businesses which own these kinds of assets. So what's changed? How have decisions that were once made by facilities managers now being boardroom issues?
So we talk about this at Johnson Controls a lot as we engage with people and share with them stories like one of our previous manufacturing facilities, what technology can do now to totally reinvent the function and operation of those facilities. To your point, not just about keeping the lights on, but literally where the building becomes a force multiplier to the strategic purpose of the organization. And our challenge is not in the technology that can reinvent how a building, in this case, our manufacturing facility works, but it is in that mind share, that C suite mind share. So, the specific example, this was one of our must run, absolutely essential manufacturing facilities. It was a manufacturing facility that had a huge backlog. But what happened? The lights kept blinking out, the operating machinery kept blinking out. Not good when you needed that production to be moving seamlessly and smoothly. Came in with the story, not only can you upgrade this building and this operation to be cutting edge, to be super resilient and reliable, but you'll be a good guy for the planet because we'll massively cut emissions. Most people, when you say that, they reach for their wallet because they're like, oh, if this is good for the planet, it's going to be bad for profits. And so we better watch out. The upshot was, as we had the chance to deploy the technology, efficiency, electrification, and digitalization, we absolutely made 100% cutting edge reliable operation, cut emissions by 43%, and saved the business $1 million a year in operating costs. When you can deliver that kind of outcome, Felicia, they got to let us out of the basement and let us into the boardroom. This is a strategic conversation. And it's interesting for some of the reasons you are hinting at. These issues are pushing themselves into the C suite like they never did before. And maybe just as a teaser along those lines, for the first time ever with one of our biggest customers and clients, we got an order, a purchase order that said, we need you in building this operating equipment for us to anticipate climate change. And so we need you to build us a resilient set of systems that will drive our success, not only today, but years into the future as we see the whites of the eyes of a rapidly changing climate.
Where it gets really interesting, and we're going to see this increasingly over the next few years, is the importance of resilience. And in this sense, I mean adaptability, because a company's ability to adapt to the pressures of extreme weather is going to have a fundamental impact on investor perception, in cost of capital, in insurance costs. So what you're talking about is a combination of increased operational performance, reduced emissions, money saved, and potentially hedging against future pressures. To me, this is a very exciting reframing of why we should be taking action and why technologies like these are so important.
Precisely. And where the smart enterprises are going to blow past the old idea of it's good for the environment, it's bad for the economy. We might do it because it's kind of the right thing to do, but certainly it can't be strategic, for us in terms of a competitive advantage. But let's look at another example just right on this point. So, a major life sciences company, a pharmaceutical company, healthcare company. This is a company that is in the business. Their brand is making and keeping people healthy. That company also then decided to stand up a brilliant new shiny central headquarter building in New York City. Okay, all good. Except if a company wants to burnish its brand, it's about keeping people healthy. There was a new reality to be dealt with, and that was the reality of massive wildfires in Canada. What does that have to do with an office building in New York? This building, because that company got it, that they could not afford to have their brand tarnished, that their employees in that building would be anything other than emblematic of healthy people working in healthy conditions. Remember that image of the analog building I painted?
Mhm.
Here's the difference with digital systems because this company got it. That building now processes 1 million data points a minute. And those data points had the building tracking the wildfires in Canada such that it knew precisely when that big orange plume was going to arrive in New York City and autonomously then switched from a building that was bringing fresh air in, a lot of ventilation, to one where the ventilation was totally shut down in favor of filtration. And so the indoor readings of air quality in that building remained pristine, giving that company not something to be worried about, but a bragging point in terms of end to end. We are the company that means good health. The building was an essential part of that story, and the building becoming resilient to a changing climatic environment was an essential part of the strategy.
I love that. And that actually brings me to another question, because obviously, when we're talking about buildings, most people first think of the homes they live in or the buildings they work in. You've mentioned manufacturing hubs. We've talked about a head office, but you did talk about flickering lights and a problem operationally. One of the things about a city environment is to function, we actually depend on mission critical assets like hospitals and transport hubs and data centers, as well as offices. So I suppose there's a question aside from the individual asset, how is climate pressure actually changing how the network is supposed to be managed, how those assets need to be operated within a wider network?
So I think we see a couple of forcing functions that all lead in the same direction. And it's something you touched on at the outset, which is we have a massive amount of energy and resources that today we either don't use at all or literally we throw out.
When you talk about that we waste or that we throw out, are you talking about things like waste heat? Or what exactly do you mean?
Waste heat, waste electricity. Let's take a couple of specific examples. So, we're all talking about and looking at things like data centers. So, in data centers in the UK, for example, there is enough heat right now generated by those data centers that if we captured it and put it to work, it could literally heat 3 million homes. And that is free energy that we could put to work right now. When we don't put that heat to work, it compounds the problem. Why? Because we then separately are consuming more and more electricity in order to cool places down and dissipate that heat. Second, how do we dissipate the heat? Typically and historically, we have built what's called a cooling tower, where then we are boiling away tons and tons of water just to get rid of that heat. But hold on, we have equipment and technology, heat pumps today that can capture that thermal energy, that heat, and put it to work to heat our homes, to create hot water, to create a competitive advantage for industries that are process industries. So pharmaceuticals, food and beverage, chemicals, pulp and paper, they all need heat in their processes. Why throw that heat away when we could put it to work, free heat to boost the competitiveness?
And that makes a huge amount of sense, especially in a world where a major part of the conversation is starting to be around water scarcity. Because the trouble with water is when water is where it shouldn't be or isn't where it should be. So managing water is going to become an incredibly important part of operational processes. So actually getting rid of cooling towers, it's a double benefit. It's managing to reuse that heat to improve performance, but it's also taking wasted water out of the equation, which to me seems to be a very strong network benefit.
Well, and I think we see this touching a very deep chord with people around the world. They understand that water is precious. And when they see that there is a threat to the availability or the reliability of their water resources, this is something that has had people start to question, wait a minute, what about the social license to operate? We have concern about this. The good news, again, is that we have the technology today to totally avoid with at Johnson Controls. When we work with data centers, one, we immediately cut the amount of energy they need by 50% and more through our super efficient cooling systems, but we achieve the cooling with zero consumption of water in almost all circumstances. Coming back to painting the picture of how big these resources are that we could tap if we just decided to pay a little attention. So I mentioned process industries. So across the continent of Europe, process industries spend more than 60% of their entire operating budget for the natural gas that then fires their processes to create heat. So an enormous amount of money. However, they immediately then reject 70% of the heat that is generated. And by the way, 70% of that energy was created by fossil fuels. To date, we haven't put heat pumps to work. Okay, say we burn the natural gas, we create the heat, and it drives the sterilization part of a manufacturing process. Well, then we throw out the heat that comes off of that process and we start over again. We burn the natural gas, we generate the heat for the pasteurization part of the process, etc. But where a heat pump comes in is hold the phone, generate the heat on, and then you can cycle it through and use it many times over, such that this is a volume of energy that would meet all of the heating needs of the entire continent of Europe and the UK combined. And we're starting to talk about, I think, the strategic relevance of sustainability considerations and smart climate action. There's another dimension when you talk about thermal energy and natural gas, and that's national security. We've seen two major shocks: the Russian invasion of Ukraine and the Middle East, the Iran war, that have brought to mind very clearly that our waste of energy, our reliance on certain sources of energy, presents a national security challenge too. So what can we do? We can turn that around by deploying heat pumps where we massively cut the energy bill, where we massively cut emissions, where we preserve water, and at the same time, we're certainly bolstering national security by ensuring the resilience and availability of domestic energy resources.
It brings very strongly to mind the question of trade-offs. Are you paying for something now? Are you paying for it later? Is it a national security issue? And that makes me think about the figures you talked about, because they're phenomenal. And if you're talking about the process industry alone, it does seem like a no-brainer. That is something that everybody should do. In reality, there are far more complex challenges, and something I come across quite a lot is companies who are interested in deploying new technologies, finding new ways of doing things, but are deeply concerned about the operational impact. So one of the things that I think we need to understand at an operational level and possibly at a system level as well is when the systems get stressed, where do things tend to fail first? Because I'm thinking about the challenges for a manufacturer if they're implementing an entirely new process. Well, what if they take a production line offline and there's a problem getting it back online? And at a system level, what impact does a major disruption have? And how do we get people to do things differently?
So I think it's not one size fits all. So when you think about the hard to abate from a climate change point of view sectors, things like steel and cement, I think we have to acknowledge that technology is still an evolution there. And that's a tough challenge to change those operations in a way that also would be more sustainable, because we're still building, whether it's going to be hydrogen systems or what kind of systems can help us to evolve technology in sectors like that. I shared the example of our manufacturing plant. In many, many instances, really what goes wrong is related to the natural tendency that companies have to defer maintenance. Because when you have capital available, most companies want to put that to growing, to building the new thing, to building out lines, as compared to going back and upgrading and repairing the stuff you currently have. And it's more, let's use the dollars we have to grow. And I think what you point out to is also a very real challenge, which is if I decide to take a line offline in order to upgrade it, can I afford to do that? And our experience is that when we come in and we work with leadership and we orchestrate these upgrades, in our case, it was the exact opposite of a disruption to the business. The disruption was happening because we had 60-year-old equipment in the building that was prone to failure. And the other piece of this is that's a very real concern is that upfront capital. So I mentioned in the case of our own facility, for example, or I could give 100 examples of businesses, hospitals, institutions, a football stadium, for example, where far from increasing operating costs in that football stadium, for example, it's a $53 million in operating saving as we vastly improve the efficiency of the building. But what about the upfront capital? You still have to pay for that new upgraded operating equipment. Where does that money come from? And this is where, again, it's so important for us to be able to get out of the basement and into the boardroom because there are new business models and partnership models where a Johnson Controls, for example, will pay for the cost of the equipment itself because we are so confident of how much we are going to save in energy bill that we will agree to just be paid as a percentage of the savings we achieve. But to have a conversation like that, a new and different kind of business partnership, obviously that requires a strategic level of conversation. These are blockers, Felicia, but they need not be action stoppers if we can have a strategic conversation of what's possible on the technology side and with respect to new business models.
What I love about that is the ESCO model has been around for a long time, and this idea of payment being returned from savings makes a huge amount of sense if the capital's there. And I think that sort of leads me to a question. How do you decide where that investment will have the greatest impact? So it's one thing if it's a major project and they can work with the Johnson's Controls and actually use that model of the ESCO and not have it impact on capital flows. But capital is a huge issue for every business. How do you go about deciding where the capital you have will have most impact? Because from the sounds of things, one of the things you're saying is they should probably spend more of it on maintenance. But how do you decide across large portfolios, or especially on the maintenance point, aging portfolios?
So, two approaches there. One is just when we go into an operation, we do a very thorough analysis of where is all the energy going out the window right now. So where is the treasure trove of savings that we can achieve in an operation of a university, a hospital, school, a manufacturing facility, a data center? But the second is we look for the sweet spot. We look for where we can not only fix a problem, but where we can magnify an opportunity for our customers and our partners. And here's an example. I go back to the hospital space. So in typical hospital, like any major organization or institution, there are huge savings we can achieve from the efficiency point of view. Okay. But the CEO of the hospital is really busy. So, how do we get his or her attention? The sweet spot might come when we say, hold on, the sensors and the control systems that we will deploy to make sure your HVAC isn't too hot or too cold and where we'll save your energy bill 30%. Hold on, those same sensors of temperature, humidity, pressure can detect and destroy viruses in the air. So, Mr. or Ms. CEO of a hospital, you're not just doing well by your bottom line because you just cut your energy bill. You're now going to be able to brand yourself as the one hospital in town where there's no hospital acquired infections. So That's the sweet spot. And when we have a chance to work intimately with our customers and partners and know what matters most to them, that's the kind of huge win-win we're able to bring together.
That's a remarkable offering and something I think a lot of people who are in hospitals would be very glad to hear about. I think that brings me to this discussion about data and digital tool. In practical terms, aside from the rather spectacular image of a hospital that can stop viruses spreading, what operational decisions can be made differently because people can see what's happening inside buildings in real time?
Every one of us has a great role to play. And when we have these digital displays in buildings, it can empower everyone to be an actor on the scene, watching the impact of their initiatives on the overall energy or water consumption of a building. And to just give one example of that, there's a phrase sometimes that people use of vampire electricity consumption, which is electricity that is consumed just by virtue of all of the gadgets, gizmos, and equipment that we leave plugged in all the time. That plug load is enormous, and your listeners will Google it up themselves. But I remember a number of significant double digits of the overall energy bill. That is all about that phantom vampire load, that plug power that everyone can be empowered to do something about that when you're going away for a weekend, unplug the coffee maker and the toaster oven, etc. And in your offices, unplug your monitor when you're leaving for the day. With the digital system, people can not just in the abstract feel good about that, but they can see physically, tangibly the difference they just made.
Okay, now I love that for individuals because it's a positive thing that people can do, helps them have a sense of agency. But I'm thinking more specifically, what is it that operators can see? Is it the energy consumption, the where people are, what they're using? And I think that leads me to that question of AI, because AI and automation are increasingly being used to manage these complex issues. One of the challenges I always think is where does human judgment come in? Because if there's an automatic cutoff, and I remember being in a building and the lights went out and I waved to try and get the lights to come back on because they were motion sensors, only I wasn't tall enough or in the right place. And so I had to leave because I couldn't get the lights back on. And it was a while ago. I'm sure the technology's got better. But how do we make those decisions? What are the things that are in place that we should be aware of? And where does human judgment stay essential?
So I do think that humans remain in the loop. Yeah, as we have the benefit though of much more intelligence to inform the decisions we might make. Whether that is in making the final decision in terms of that building that is on ventilation and should it be on filtration, etc. Some of that you can do totally autonomously. Some of it you can reserve the human to be in the loop. We see a mixture in terms of the comfort level. And there's another interesting dynamic that is having more and more building owners and operators appreciating digital systems specifically to enable people to remain in the loop. And what do I mean by that? Around the world, we're seeing a great retirement. So, technically skilled people, building trade people who are retiring, with the result that in the US economy, for example, tens of thousands of positions for technically capable people going unfilled as we have a shortage in skilled labor. And I know in Europe the same is true. What does that mean? That means that digital systems, far from displacing a human being, are now the absolute must to magnify what is a smaller human labor pool to be able to still stay in the know on a single building or across vast campuses. And that's where we mostly see digital systems being put to work to magnify and amplify the ability of skilled technical people to stay on top of those building operations. If I could share a different example, though, just on this point of, What does intelligence mean in terms of helping us achieve goals like being better stewards of the climate, like cutting energy bills, like keeping indoor spaces healthier? If you could just envision that massive chiller or HVAC system that is in the basement of a building, 75% plus of our new product R&D budget is dedicated to sustainability and tackling climate change. The biggest manifestation of that is every generation of machine we put out is vastly more efficient than the one it replaces. So some of our leading machines, for example, are 65% more efficient than even what the most demanding standards would require of us. However, that machine is sitting in the basement of the building with no intelligence coming into it. Okay, it is heating or cooling efficiently, 65% more efficiently than the standards would require. But what if all of a sudden the security system and the lighting system on the fourth floor of the building could communicate down to the HVAC in the basement and say, hey, HVAC, we know you're sending that heat or chilled air up here very efficiently, but there is no one on the fourth floor. So stop sending it up here, period. Obviously, that could be a hockey stick inflection of improved performance from an energy efficiency and from an economic point of view. You're saving vastly more energy and dollars and cents around that energy with that intelligence that could come into the system. And this is where I say go from kind of inert, dumb, if you will, bricks and mortar to something that becomes more organic, an agile system where a building almost becomes like then a battery that can productively contribute to a healthy energy system in a community or a whole country.
Because as you were talking, all I could think about was demand response. This idea that when demand increases in one place, motors, generation, whatever it might be, that aren't needed, that can be drawn on. In the UK, the National Grid has been doing a huge amount of work on this. And the ability to manage the grid intelligently, the ability to actually maximize the use of what is already out there could be really transformational. Although, to be fair, I've been talking about this for 20 years and we haven't quite got there yet. When you talk about the image, the concept of the building as a solution, part of a wider network. So I'm thinking about a lot of the focus in sustainability, a lot of the excitement is around the construction of new buildings. How have they been designed? What materials have been used? Where are they being put? But the point is that most of our cities already exist. We know that even by 2050, over 80% of all the built environment is still going to be here. So I suppose the question then is, what are the practical challenges of improving performance in those buildings that weren't designed for today's conditions? Is it connecting them? Is it something else?
I get this question often in Europe in particular, because so many of the magnificent buildings are buildings that have been around years, decades, sometimes a couple of centuries. And the question is, well, is that technology, heat pumps, for example, are they appropriate for these buildings? And the resounding answer is absolutely yes, they are. The technologies can be and are configured, maybe not as old as some buildings in Europe, but for example, in the White House complex, historic buildings, buildings where there is a great degree of care as to what can or can't be changed. Those are buildings now where we have deployed our technology. We're electrifying the systems there, cutting carbon, cutting costs. And similarly, Princeton University, for example, a historic campus, buildings that are 150 plus years old. There too, we have just been working on and nearing completion on a total electrification of that campus. So that campus will have zero combustion and zero cooling tower. The numbers, as I last saw them as we were putting this project together, was anticipating something on the order of a 60% plus reduction in their operating costs and a 70 plus reduction in their carbon emissions. Again, historic campus, older buildings, but systems that can be configured to achieve very impressive outcomes from an energy security and energy sustainability and a profitability point of view. It may take a little longer, it may take care, but the configurability of the systems is certainly there, and no building should be considered out of the running significantly to improve its operating performance.
If listeners took one thing away from this conversation, what would you most want them to understand about the role that buildings now play in resilience and competitiveness and the functioning of the modern economy?
We have a massive opportunity today to set the bar high and expect performance in these places where we spend 90% of our lives inside the built environment, for those buildings to become strategic multipliers of our resilience as an economy, our sustainability as an environment, our health as a people, and our vitality as communities that want to thrive and be places of joy and productivity and healthfulness today and into the future. Insist on it. The technology is here. It is absolutely possible. And we just need to say we expect that level of performance.
Katie, that is a wonderful note to end our conversation on. And I especially appreciate the joy and optimism because I think that's a hugely important part of actually encouraging people to do things differently. So thank you so much for joining us today. I really, really appreciate it. Over the course of this arc, we've actually explored how infrastructure is designed, how increasingly complicated industrial systems are becoming more intelligent, and what it actually takes to keep the places where we live and work functioning every day. And one of the ideas that I think has emerged is the next phase of transition isn't about building new infrastructure. A huge part of the challenge lies in operating the infrastructure we have more intelligently. So whether we're talking about buildings or transport systems or energy networks or industrial facilities, the systems we depend on are being asked to do more than ever before. They need to cope with changing climates and changing energy systems and growing digital complexity and rising expectations about resilience and performance. So that also means that sustainability itself is evolving. It's no longer just about setting targets or deploying new technologies. It's about making better operational decisions, improving the performance of existing assets, and finding ways to use all of our resources more effectively. The transition isn't something we're going to build, it's something we operate. So, Katie, again, thank you so much for joining me today and for sharing your insights. And thank you to our listeners. I hope you've enjoyed this episode and found it useful. If you have, please do follow or subscribe. Leave us a review if your podcast platform allows it, and share the episode with anyone you think might enjoy the conversation. Thanks for listening, and until next time, we're still shaken, not burned.